Hello, my name is Aylin Doryan. This is my second year at Bilkent University as a molecular biology and genetics student. My PHYS101 project aim is to understand the mechanism of torque by adjusting its components and understand the rotational equilibrium conditions. In my experiment, I used balance, spring, objects, ruler, wooden stick, and rope. Objects' masses were 20 grams and 10 grams. To accomplish the purpose, center of mass of a stick is measured. It is hanged by a rope and is in equilibrium. Then, to understand the relationship of the force and momentum arm, two objects are put onto stick. Two objects' masses are equal and it is 10 grams. So the force they apply should be equal. According to the rotational equilibrium theory, their momentum arms should be equal. So I will measure their momentum arm by using ruler. Their momentum arm are equal. As we expected, this system is in the rotational equilibrium. So in order to test the relationship between force and the momentum arm, I will add one more object, which is 20 grams. Then I will put on the exactly same place. As we can see, this system wasn't in the equilibrium, so these masses created a clockwise torque, and then the system turned rotationally. This time their momentum arms are different and they are measured, but the system is in rotational equilibrium because net torque applying on the sticks are same and equals to 0. Since the cross product of force and momentum are equal, system is in equilibrium now. In the first part of the experiment, mass of objects were same, so did the force they were applying. Since the radial distance to rotational axis were same, the magnitude of torque they were applying were same as well, and the net torque was 0. Therefore, the system was in rotational equilibrium, as expected. In the first step of the second part, net torque was not equal to 0, so the system rotates in clockwise direction. However, in the second part of the experiment, the system was in rotational equilibrium, even though the net torque was not exactly 0. Yet, the magnitude of the net torque was 0.006. Therefore, it is very close to 0. The reason why net torque was not 0 is because when the ratio of forces applied by objects was 3 to 1, the ratio of radial distances was supposed to equal to 1 to 3, since they were inversely proportional. However, in this experiment, due to error, this ratio was 1 to 2.84. It is very close to expected ratio. These experiments demonstrated the conditions required for rotational equilibrium and mechanism of torque.